we live? Awesome. We are live. Yay! Just look over there because that's where I see myself. All right. So welcome back to another amazing stream. Yay! Let me do some stuff here, and we can start in a second now. Just wait for people to get here. And people, it's already getting here. Cool. Hey guys, what's up? What's up? Did you miss me? I'm doing great, Bob. Hello, Bob. Hello, Steven. Hello. Hi, Soil7. What's up, everybody? You guys miss me? I bet you didn't. But that's alright. That's alright. I did miss you guys. It's been a while since the previous stream we did. It's been a while. It's been a while, right? Let me just switch here really quickly to set the chat there. And I haven't been changed the topic, which is terrible. Intro to VOPS. Terrible YouTubing. Terrible YouTubing on my part. So how you guys been? I took some time off. I was out of town in the beach. It was amazing. That's the greatest week ever. On the beach, on the ocean. It was amazing. Yeah, pretty cool. Got some rest and ready to kick some ass, which is great. It's always great to take some time off and just come back with pumped. Alrighty, so I haven't even opened Houdini today. Well, yes, today, but not at this moment. So how you guys been? What do I need to do? Yes, he's here. Just setting my scale of the UI so you guys can see it perfectly. Hey Riz, what's up? Cameron, does your Redshift shading course cover particles? No, we don't cover particles. Particles is really simple to do. Why would you need that for particles? It's very simple, dude. It's very simple stuff. It's simple. I think I already did a live stream on that, didn't we? Did we already did a live stream on particles? I think we did, didn't I? I don't know. It's pretty simple, Cameron. Hi, by the way. You just activate the particles thingy and you render them. Yeah, Redshift is pretty simple. It's just ridiculous. You don't have to do anything anymore. Alrighty, I'm gonna make this bigger. Alrighty, so let's start with some stuff. Hey, Karen from Jebron, Armenia. Wow, Armenia, that's awesome. Yeah, Bob, that is on the side effects website. They mentioned that it's a talk that they're gonna give at SIGGRAPH, which sadly I'm not gonna be at SIGGRAPH. Some stuff happened and I'm not gonna be able to make it, so Yeah, sadly that happened. Makes me sad, really, but it's just totally can't make it. All right, let me get the Patreons for past month, because we are doing the giveaway today for the 10 plus tier of Patreons. So that's awesome. Let me see. So if you don't know, every month we do a giveaway for our training on our titles that we have on the website, and everyone that it's on the $10 plus tier has a chance to win a title of ours completely free, just by helping us with Patreon. Hey Bess, alright, I will try to do my best, dude. Hopefully I don't disappoint you. And every month we give away some training, which is great. Some people can just actually 2 months ago, Luis Roman won, and he just pledged $10 and he won a training course, which is great. That's awesome. But now again, I forgot the site that I do the giveaways with, so I'm gonna have to pull that site up. So you're gonna have to see my face for a little bit longer, which sucks, I know, but I'm sorry. Have to see my face. Sucks, right? So, how you guys been? I've been so overwhelmed by work. I have so much work. Oh God, the work. Oh my God. It's alright. But yeah, I've been doing a lot of stuff, and I want to. The studio is growing, which is amazing, and it's super pretty, really cool that the studio is growing. So yeah, it's really nice. That's what I've been doing. What you guys been doing? Nothing? Okay. Alrighty, I'll let you go then. So let's start with some news, because we released some new training. Oh, I think I left something playing. Let me just alrighty, that's the one I want to have here. And let me just open mixed training, and my big face is off now. Yay, no more big face. Awesomeness. Let's see, let me just move this Houdini window to its place where it should be. Come on, Houdini, you know where you need to be. You know your place. I guess there. Alright, so if you go to mixed training, you will see there is new training. Let's go back, and it's this one, the artist guide to technical direction in Houdini, volume 0, HScript. Yeah, that is 2 mouthfuls, man. Stephen, and it is by Stephen G. Tucker. I wish you can see here I have access to the course because I own this thing. Of course. So And people ask, why volume 0? Why is it just volume 0? Well, volume 0 is because in programming, or technical directors and all that stuff know that technical stuff, you always start counting from 0. So that's why the volume is 0. It's not because it's less important. It is really important, the information that you have here. And if you go check it out, there's everything here. You can see, we can read more about Stephen. He's a senior VFX at EA Motive in Montreal at the moment. He worked at Side Effects. He worked in a few studios like Stars, Dr. D, Digital Domain, and all that stuff, which is, Stephen knows what he's talking about. HScript is not the same thing as VOPS or VEX. HScript is the expression language, and Houdini it's what you use for expressions and all that stuff in Houdini. So it's used for different things. It's not used for the same thing as VOPS and VEX. It's used for different things. And if you want to know what you learn here, there's all the topics are here. We are taking the time to make it more detail in the description, so you really know what you're gonna learn here in each chapter. So we have each chapter with a little description of each one of the chapters here, so you will really know what you're gonna learn here. So there's no more and no less than when you are reading here. Well, the information it's amazing. It's not, this little text doesn't make it justice, but you should really check this out. It's really a nice course, and it's really freaking long. It's 7 hours long, and Stephen takes this really nice approach, so you really understand everything. So that's great. He takes the time to explain everything, which is great. And well, this is it. This is our new course. This is Stephen Tucker, our new mentor that joined Mixed Training, which is amazing. Yesterday I was talking to another mentor, which is going to be joining us. Well, it's already joined us, but it's working on some training at the moment, which is going to be great to have. The company is growing, which is amazing. And we're doing a lot of training to help you guys in different ways. So if you guys are interested in HScript, please go and buy the course. It's really nice. The course is amazing. I'm guarantee you're gonna learn a bunch of stuff, and as the title says, is for Artist's Guide to Technical Direction, which is treats you as someone that doesn't know programming, and it starts teaching you programming. And if you want to get later into VEX or VOPS in Houdini, learning HScript is a really nice start, because it's quite simpler, and it's shorter. Somebody said that it's like the shorthand coding. Well, it's not really shorthand coding. It's actually coding. It's a scripting language. So there it is. The new course. It's gonna have more volumes. Stephen has plans to do a few more, so which is gonna be great. The other ones are gonna be for VOPS and VEX later, I think. There's no comparison between HScript and VEX. There's different things. HScript is used for some things. VEX is used for other things. So it's not languages that compete between. It's not. You can't compare Python to VEX because they're used for different things. HScript is used for different things than VEX. So it's not apples to apples. So that's HScript is different. It's for scripting other things. Alrighty, so that's that on the. Also, I want to tell you about this. Which, let me put this in a new. If you don't know, we have a Discord. Here is a Discord server. Here it is. There's a lot of people here. Or right now there's 20 people here. We should make a live channel here. Maybe when we're live, we can maybe chat here as well. But you can see there's a bunch of people here, and people ask questions. We hang out. We have fun. We just chat, or people share their the work in progress. Like this is what one of you guys is doing, which is great. He's doing my Redshift training, but he wanted to model something different, and he did this in Houdini, and now he's shading it with the curse, which is amazing. And yeah, people share their progress here. We chat about stuff. You can see here's the scene that he was doing for the shading course. So he decided to do his own scene, which is great. You can see people share tools here and stuff, which is amazing. I really invite you guys to join the Discord server, and this is the URL. That's the one. I'm gonna put this in the. This should be in the description already, but if not, I'm gonna put it there. Join the server. It's really cool, really nice chat. We can talk about anything. It's not just specifically about Houdini. So yeah, I invite you guys there if you want to have some chat, some fun. It's cool. Okay, cancel. I don't want to close that. So now the new course I already told you about, the Discord URL, it's done. So now let's talk about the giveaway, and then we can move on to just our into the box, because I want to put some time to that. So let's see, let's put our random name picker here. So there's like 8 people today, 8 people, and out of those people, 2 already won. So if you're not supporting us in Patreon with $10, you're missing out, because you can just win training. You can win training with $10. $10, because there's 8 people there. So your chances are amazing. If someone that already won wins today, he's gonna be, well, I think he's gonna be really happy, because he's gonna have 2 training titles with $10 a month. That's really cheap, really cheap. So if some of you guys tell me like, do you make discounts? I don't, but you can do this and win some training for really, really low. All right, so let's spin this off and see who wins today. All right, let's do it. Let's go. And I do these things live so you guys see who wins. Oh, Jeremiah Cook. Oh, cool. So Jeremiah Cook is the winner. Awesomeness. So I'm gonna put this in my notes. Wins. Jeremiah wins. Awesome sauce. Let me save that. Don't see my window. I'm just kidding. Where did I put that? Patreon. This is what, July? Yeah, right, because we're in August. So now we're with that out of the way. We can start with VOPS. Let's start doing some VOPS. Oh, yeah, so Bob just said that the link to the Discord it's on the note in the description of the video. So if you want to join the Discord, please go ahead and join it. Join around, whatever. All right, so let's do some VOPS, and let's talk about what VOPS is. So VOPS stands for what it stands for? VEX operators? What? VEX operators? Are you kidding? Did you just say VEX operators? Well, if you go to math or the old shop context and you create anything here like the principal shader, guess what? This is VOPS. And let's go here and create the principal shader again. Guess what? This is VOPS. Let's create the Redshift node, Redshift material. Guess what? This is VOPS. Yeah, you've been using VOPS for a while, and if you do like RS texture, guess what? You're doing VOPS. And guess what? You're actually generating code right now. If you go here and say, oh, VEX VOP options, what? And you go here and see view VEX code, what? VEX code? If you do that, guess what? You just generated code. Yep. Yes, you did. You generated code with that stuff. So that's awesome, because VOPS is actually VEX operators, which is just a visual way to create VEX. And this is how VEX started in Houdini. Let's go here, see if the VEX code is yep, there's the VEX code for the shader. If you want to write this in VEX, you can write it. All the code here for the principal shader, it's here. It's even commented. So you can see VOPS is just VEX. But it's some people prefer to use VOPS instead of just writing the code directly. It all depends on how you prefer to use stuff, or how you think. Some people like to use both. They use VEX and they use VOPS. I use both. I use once for one thing, once for another thing. So in shaders here, I never use the code. There's an inline code node actually, and you can write VEX here. And this has been there for a while. You can write VEX. I think the first incarnation of VEX was like this. You could write in the inline node. You can write some VEX here. You can see there's no output because you have to create an output, what kind of output you want, and then it shows the output. You can even name it like output mix. So that's the output mix there, and you can plug this to whatever you use it for here in the code. So we're not gonna be coding today. We're gonna use VOPS. So I just wanted you guys to see that VOPS is not something new. If you already been using shaders, you already been using VOPS. And VEX actually started for shaders. The first thing that Houdini used VEX for was doing all these shaders. And all these nodes that you see, like these patterns, let's see, wire pattern, all this stuff, all these nodes are just VEX. If you want to see the code, you can see the VEX code, and you can see this is the code that generates that node. Hopefully I make myself clear. VOPS is VEX in a visual way. Alright, so now after a few years, VEX came into, actually VOPS came into surface operators, into subs, into geometry, and then later came VEX directly, which is now everyone wants to use VEX for some reason. It's cool. It's not always necessary. So just choose your battles. Don't use it just for everything. So, but yeah, later we got VOPS. You can see the new panel there for the help in tab 2. Helps you to gives you a description of what kind of things these things do, which is pretty cool. Look at me, I'm proud. I'm proud of my tool. Look at me. All right, so if you type Bob there, as I just did, Bob, there are different kind of Bobs. The Bob network is the old Bob network, so kind of ignore that, but I really like that Bob icon there. That icon's pretty cool. So if you type Bob, let's go and ignore that guy. Let's think there's not there. So there is the attribute Bob, and then and the point, primitive, and vex Bob are actually the same exact thing. The attribute Bob is the, let's say, the main one or the father of the other ones, and the other ones are just the same one with this parameter changed. Alright? Alright? Alright. So there's a few other Bobs, like the volume Bob, which is used specifically for Bobs, and the height field Bob, which is specifically used for height fields, because actually I think these two guys are the same, because height fields are volumes, and we can try. Yeah, I knew that was gonna happen. So this is the volume Bob, and if we create the height field Bob, it's exactly the same thing. Look at that. Oh, guess what? I'm the same guy. Woo, woo. Just with different name. All right, so there's not even a change here. Oh man, that's great. Let me just make a note of that pretty quickly. Let me just make a note of that really quickly. High field Bob. Got it. All right, so the one that we're gonna use, I always like to use the attribute Bob. I don't want to use point Bob or primitive Bob or vertex Bob, because it's the same thing. It's the same thing. Let's see, vertex Bob. It's just the same thing, but it's changed this value to vertex. Vertices. All right. So I never use those other Bobs at all. I don't use them. I don't know why they are there. I always just use the attribute Bob, and if I want to change this, I change it. I don't know. I don't use them. So yeah. All right. So let's create some noise here. So Karen says, what's the more important and often used Bobs? I don't know. I could consider a few important ones, but you might think there's other ones that are more important. It just depends on the uses you want. But yeah, all right. Let's go inside and see what happens here. So when you click inside here, there's this scary world of Bobs. Let me just make some space here. The scary world Bobs, it's not scary at all, because we are dealing with nodes again. We know nodes. These nodes are different. These nodes go from left to right, so they're good. So there's some globals here, and there's some outputs over here. Globals, outputs, globals, outputs. I guess one of the most used nodes is the turbulence, the turbulent noise. Turbulent noise is pretty used a lot. Add, multiply, fit, range. I don't know. There's a bunch of them. All right, so. But as you can see, you can create the nodes exactly as any other place. I'm using tab 2 for that, but if you're using regular tab, it's the same thing. Add multiply, etc. It's exactly the same thing, right? So you create the nodes the same way. And let me explain what the hell is this thing is here. So this thing is here. These are the attributes that could exist in the geometry or might not exist. This is our globals that Houdini knows about in a way. But you can see there's B for velocity. If you put your cursor over those, some of them say this is force, this is age, this is life, this is the ID, CD, blah, 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 blah. And it's really important that you recognize there's also the type. So that's an int, that's a float, that's a float, that's a vector, vector, vector. And the colors tell you what kind of data they are. If you go up here, you can see we already have a point attribute there that it's P. So we can actually, we always have P. Sometimes we have P, and we have to go P. That's a really bad joke. We always have P here, which is the position, because whenever you create something, it has to have a position. If it doesn't exist. So we can control position here, and you can see position. You can have a wire there. Woo, a wire. You can plug it to position. So this is basically the flow. The globals are here. They go from here to here, and in the middle of this, you can modify it. So that's what's happened. You always have to have something that's gonna fit there. You don't always have to have the globals, but you always have to have the outputs. Even if it's this, even if it's not this node, you can output something else or other values that are not here. But you always have to have something that outputs a value. So this is the flow, let's say, and you have to put stuff in the middle, because if you just plug the current position to the position, it's like, all right, current position to position, it's equal to the same position. All right, we learned something. So, but if we start adding, let's say, to the position, we can create an add node and say, all right, I want to add to the position, but since this node doesn't have any attributes, we can add anything. It has another input, but there's a few modes of adding. You can add a constant here. Let's put the add constant, which let's connect it there. Now you can see this guy does have a value here and a signature, which is basically the type of value you're gonna be adding. So right now you can see we're adding already 1, and you can see if we slide this guy, we are getting the value, and we can actually see the value here, which is pretty cool. And here in the 3D view, you can see we are actually moving the points. It's kind of expanding, kind of growing, because this position is a vector, has X, Y, and Z, right? So we are adding to the 3 positions at once, and it's kind of growing. It makes sense. So if we just wanted to add in the Y direction, we can break this vector actually with the let's create a vector to float. You can see with tab 2 how easy it is to get those nodes. Just VF, vector to float. There it is. So the vector to float takes a vector and it just splits into the 3 values. So now if this is X, Y, and Z, this is X, Y, and Z. It doesn't name it like that, but you know, because I'm telling you. Alright, so now we can say, alright, I want to add to the Y value, so I'm going to plug that. And here, I don't want to plug it directly. You can see this line, it's kind of dashed or dotted, because this is now a float, because we splitted the vector, it's now a float. If you don't know what I'm talking about, please see this video. a couple of times, and just know that a vector is composed of 3 values, x, y, and z. Each one is a float because it has dot 0.1, 0.3, whatever. That's a float. It's composed of 3 floats. So now we're getting this float, and we're trying to plug it back to a vector, and that is not bad, but it's not right, because it's gonna plug this value to the 3 values, and you can see now our geometry is actually nowhere to be found. So something funky happened. Alright, so instead of just plugging this value directly, we are going to remake the vector. So we're gonna use the opposite of vector to float. We're gonna use a float to vector. Look at that, even the icon tells us what it's gonna do. Woo! So we have this guy here, so we're gonna build a vector. So this is gonna be now x, y, and z again. So right, we're gonna plug it here, but by default it's gonna plug it in the x, which is not what we want. We want it in the y, and now we have the right thing. But see this, the other components here, x and y, are actually 0, x and z actually. So instead of having these guys being at 0, and we only want to modify y, we want to just plug the original y and z values. And look at that, our geometry is back. Yay, geometry is back. And now we can go here to the add constant, which is adding only to the y value, and we can modify it. Look at that. Woo, it's moving. Ooh, 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 ooh. That was awesome. Not really, but it's getting there, right? So it's, you can move this guy up and down, up and down. All right, so what we can do, what if we don't want to just add one constant value to all the points? Well, welcome to the world of noise. Welcome to the world of noise. We can put some noise into that value. So let's put a turbulent noise, and the turbulent noise generates noise, generates a few kinds of noise. Here you can see there's different noises. So if we plug this directly to the y value now instead of the other one, guess what? It doesn't work. And why is it? Well, because it needs a position, and the position, it needs to know what's my starting position, man. Feed me something, tell me something about this thing that I want to get noisy. So you always want to plug the P here to the position, or there's the rest position as well. Let's see if the rest position exists yet. Yeah, there you can also plug this rest position for something. Rest. Oh, it doesn't exist anymore. I don't know. Weird. Alright, so forget about the rest position. If Houdini doesn't want to list that anymore, then don't do it. Alright, so you need the position, and now the geometry is noisy. And then this geometry is being deformed by this noise. You can now modify this noise, and it's not applying the same thing to all the points. Now we're controlling it with some noise. So let's give it some more geometry, because we're getting crazy already. Look at that. And look at that, it's fast. Why? Because it's basically Bex. So it's fast and it's awesome. So we have this noise, and we can change to different types of noises. That's Perlin, that's original Perlin, that's sparse convolution, that's alligator, and that's simplex, and that's zero, center, whatever, noisy. Let's go for sparse, and we have that. Let's say we want to generate some mountains or something, and we want to make them bigger, and you can modify the frequency, something like that maybe. And now we have like a landscape, which if we used to do this before the height field nodes existed, but now the height field nodes are really cool to do this stuff, so you don't need to do this. Or if you want to do it, you still can do it. Let's put more geometry here to get more detail. So there we go. We have one thing, and one thing we do a lot is just basically adding to, and instead of, if you're gonna use noise here like this to modify this, you can actually skip all this stuff, because this was just to modify up and down. So we can actually use an add node and add to the current position. We're gonna add this noise, and look at that, we're adding the noise, but this noise is in one direction. Okay, so we're adding 3D noise. Let's go for this. We can also multiply it. Let's multiply this. Let's see, multiply gives us different results, so it all depends on what you're doing. So let's plug that to the position, and look at that. That's crazy stuff. Yeah, I don't want to do multiply. I want to keep it on adding. But you can see this is actually displacing the geometry in all directions. So if you don't want to do that, then you can stick with what we have here before. I think for a plane it just works better. So let's just keep this. Let's just do that. Keep our float to vectors and just add to the y component at this moment. So let's just add that to the y. There we go. Let's stick to this for now. But we can do more stuff here. Let's do another one, and now let's multiply this with the previous one, and let's make this one maybe different. Let's make it have more detail, or not, maybe not multiply. Let's just add on top of the previous one, and this, let's make the amplitude lower and the frequency higher. Not too much, and the frequency not too high, like that. And we can change this maybe to alligator, and now you can see we're making a little bit more of a complex thing here. Let's do more resolution, because why not? So we have that, and you can see now we have more complex noise. You can see if I disable this with the wrong key, if I disable this, is gonna be weird. Let me delete this multiply. Let me just cut it here. You can see now I deleted some of that noise that I'm adding here. I can make this a little bit more exaggerated. You can see I'm adding on top of the first node I had, I'm adding some of that noise there, which is pretty cool. If I make this my base noise, like my base mountain kind of thingy, and I can start doing more detail with this one other node here. See, this is the first node, and then I add more noise on top of that with the other one. And this is something that it's really used a lot in VOPS to do kind of a noise things like this. So let's go now for a sphere, now that I got inspired by that. Let's go to polygon, and it's gonna give it a lot of resolution. Yeah, what's that, 4,000 points. All right, so let's add an attribute BOP. Let's make this a rock. So we're gonna create a rock. Let me save this to LearnDay 65 VOPS. All right, so let's create a rock with this, with the things that we've been talking about. And there's a really nice noise that is called whirly, and it gives you this really sharp corners. So let's put an add. Let's put a regular original position, feed that to the noise, and then add that to the noise, to the position, and you can see now that's what the whirl it's doing. Has this really nice defined edges. This guy, it's in oh man, what is happening here? I always get the add and multiply guys mixed up. So let's see, with the multiply gives us that. Okay, alrighty, so now we can put a fit range, and the fit range node, you can fit the positions of the values, actually fit the values of any result. And what I'm doing here is taking the output of the whirly noise and just saying the destination minimum, or the minimum value, instead of being 0, which gives me this really exaggerated figure, moves the points too much into it. I'm kind of saying don't move them too int. I want to keep them something like this, and you can see we have already like a really nice shape for a rock. And we can actually make this different. Like let's go in the other direction. Like look at that, we can morph a sphere into a rock just by doing this. Alright, so we can do that, or we can even do, let's say, we add turbulent noise before we do this. So let's say turbulent noise, we add that to the multiplication of this, and let's see what we have. We have that, and let's see, again, I'm gonna use a fit range. And why is it's that guy's plugged there. I don't want you there. So alright, so we have something like this with just the turbulent noise, which this could be another kind of rock. And you can invert this. If you change those values, invert those values around, you can get the bumps going in the other direction. And if we modify this guy something like this, we can have this result and then multiply on top of this result instead of giving that. So let's now add this, add there, and now you can see we have something that's a little bit more complex instead of just being really pointy. We can even, instead of doing this, we could even, let's say we want this, we have this kind of a rock, but we can even say let's plug this turbulent noise to the frequency or the offset of the whirly noise. Let's say the frequency, see what we get there. And you can see it's kind of it's a little bit weird, but maybe because the frequency on this is too low. And yeah, that's a little weird, but you can see we're controlling what noise with the other. This is not particularly great. Let's put this in 3D. There we go. Alligator noise. There we go. So now the let's see the fit. What is this guy? Okay. We can make this. All right. So there we go. You can see this is the kind of the original whirly like that, but we are actually now modifying on top of that the shapes there, and now it looks a little bit more natural, let's say. So let's add more geometry to this, because we have a bunch of geometry, whatever. We can manage it. The worldly, I mean, this guy, it's too much right now, but you can see if I wanna modify those lines that the worldly produces, we can actually do that with this guy here. So we're actually deforming the noise, which is great. Now here we have this to control how deep those cuts go. We can do that. Now we're kind of doing a rock. We can actually maybe, before we can stretch this kind of a more into a rock kind of way. Let's see what this does. So you can see now we have this kind of a rock formation there. We can control all sorts of things. Let's say the offset also as well, and it just gives us more variation of the noise. Plugging noises into noises is just so much fun. And on top of this, we can say, all right, we have this, but we want more detail, or smaller detail on this. Let's put another turbulent noise on this guy, and put the bump, the position, and let's multiply it, or multiply it. Let's see, multiply it with this guy. And again, it's too much. Fit range, just one little bits to do with this, and we want to we can let's try add. Let's try to add to this instead of multiplying. Yeah, I'm gonna use add. And I'm gonna change this to 3D noise. I'm gonna make this way smaller, and I'm gonna make this amplitude smaller. And actually, we could do it. We could invert this. It's not giving me what I want. Yeah, it's not giving me what I want. Let's try multiply again. See if multiply is better. So we are multiplying. What did it do there? All right. Whatever, dude. It's getting weird here. Why is this guy doing that? I don't know. 1D noise. There we go. Alright, that's what I wanted. So I want to add some little bumps. Let's add more geometry here, because we want detail. So there we go. Now you can see we have more detail in this rock. And we are doing that with this guy. And we can even make it smaller, kind of like that. And you can see we're adding detail to this rock, and this looks still too like curved, so we can make it less curvy, or even more pointy if we want to. But yeah, you can do some rocks with this. And you can see you can design a system here. You want more pointy rocks, let's pointy rocks and stuff like that. So are there any questions? And you can see you can just combine noises, combine thingies. You can modify attributes. You can do more stuff here. You can export stuff to attributes. I just wanted to get you guys familiar with this, and that you can do stuff like this. And you can see this is not that complex at all, and you can do a lot of stuff, and you can promote parameters. What's up, cool BFX? What's up? You can promote parameters here, and if you go up, you're gonna see the parameters here, and then you can animate these parameters if you want. You can see that looks cool. It's like eroding the rock. That's pretty cool. You can use that for some kind of erosion effect, like it's just the original rock, and then it starts eroding, like over the years the rocks eroded into what we see today. Whatever. So yeah, you can see that looks fun. That's like a lunar rock. Let's undo that and say now we can kind of create the moon. You can see the craters and the moon, and if the craters are too deep, we can expose other parameters and make them not so deep, or add more parameters. Like we can go here and say actually here and add more frequency to the inside parts of that. You can see now we're adding more detail just on those craters. If those are our craters, we can reduce the amount of noise there. We can add noise or remove it, or you can make it the other way around and now have like spikes, and you can still control that noise there. It's all up to what you want to do. We can control it with this. You can do a lot of things with VOPS. Really, it's just fun. It's fun to play around with these things. I find that it's really fun to play with VOPS, and once you want to do this stuff in VEX, it's not so fun to play. Can you add random noise and shape to multiple rocks? Yeah, sure. Just expose your parameter there, and then you can, let's say, let's go back to when we have had like a rock where we modified, let's see, what did I modify? Oh man, what did I do? I think I changed the frequency of this. No. So I'm generating noise here. I'm generating noise here. Let's see. Let's go back to when we were more like a rock. This thing. It's what did I do? Oh, it's this parameter. It's this parameter. Okay, so that is too grainy. That is here. So that could be a rock. And if you, let's say you wanna give variations to this, you can do something like, I don't know, let's say this guy. If we do this, no, not that guy. Let's disconnect this from the offset, and this offset can generate different, can be modified to generate different kinds of rocks. You can see it's just generating more rocks. We can actually disconnect the frequency for there and put maybe more frequency in one direction, or maybe more. You can generate something like that, maybe like a space kind of rock. So you can see that's another kind of rock, and you can just make the offset, move the offset, and give it a lot of randomness to this. So every noise has an offset, and you can just offset that and give it more variation. So I'm not using this anymore. I can plug this to maybe the frequency of the other one, and now you can see the detail. It's controlled by the other noise, and you can see that it's looking pretty nice. You can have noise controlling some noise, which is, I really like that. So yeah, you can add a lot of detail and build really complex stuff with this. I know you can. I know it. So if we do something like this, you can see that's pretty cool. And if you want to add something else on top of it, whatever, or sometimes what I do is just create a mountain sub first. So the mountain sub gives me some variation to start with, and then I put that into the rock. And if I modify this this mountain, this offset here, see, we're gonna get a lot of detail, a lot of different kinds of rocks here, just by modifying one parameter here, which is pretty cool. If we give it more bigger kind of changes here, we have this kind of a coral kind of rock, and we can just modify this top level mountains up here, and we can have a bunch of different kinds of rocks here. Sometimes what I do is just put F here for frame, and you can just play and have a bunch of rocks generated for you. A lot of rocks here in the same kind of a shape, or in the same kind of a space of those rocks, right? So yeah, you can do that. Hey, Jin Song from Korea. What's up, man? Hey, Bart Bean. Hello. All right, so that's some of the stuff you can use VOPS for. Of course, there's a lot more that you can do. You can see if you go here, there's a lot of stuff you can do. You can make your own shaders. You can make all kinds of stuff. So yeah, I should just really use the displays along normal stuff. Yeah, I always forget that. You can do a lot of math functions here. There's a lot of stuff here, a lot of stuff that you can do. So I really encourage you guys to go and take a look around. There's like cellular noise, which is basically the Voronoi pattern. Let's see if that works here, because it doesn't have UVs. Yeah, this one needs UVs. Needs UVs to work. Yeah, it's not gonna work. Okay, that is not gonna work. So yeah, there's a bunch of stuff you can do. Please go and explore it. And if you have any questions, please ask now, because we're gonna end for today. Cool. So yeah, that's how you can use some VOPS stuffiness. You can say we're just generate a bunch of rocks. Like I need to populate a bunch of rocks. So yeah, you can do that. Cool. Sure, totally. All right, no questions. Oh man, time flies. No questions, eh? All right, guys. So that's gonna be it then. Again, if you can go to the site, buy the new course from Stephen Tucker. There's also the here it is, shading with Redshift. There's also new, and that's one's from myself. I did this one. If you want to learn how to do this really awesome image, but not only use do that awesome image, you want to actually learn the whole shading system in Redshift. You can go and use this baby for that. It's 6 hours long. Phew. You can see everything we're going to learn here. It's pretty amazing. Getting the color from geometry, making subsurface gathering, glass, metal, candy shaders, lighting the scene, even writing our own little connection tool there to help us do work in shading, the lollipops, some UVs, just a touch of UVs, blending materials, and more complex material, lighting up talking about lightings and samples, the render settings, and the denoiser, and that's my face. So yeah, that's about it for today, guys. And if you want to support us on Patreon, go to patreon.com/mixraining. See, there's 34 people that support us there, which is awesome. And you can support us there, and you can get a chance. If you support us with $10 or more, you would get a chance to win some training, like Jeremiah Cook just did. Whoa, my ducks are getting crazy. Alright guys, so that's it for today. I will see you next week. Have a nice time and have a nice life, and do what you do, and let's keep learning together. Alright? Awesome. Stop streaming. What's happening?